Hello guys, how's it going? I'm just gonna check that my audio and my video are properly running. Hello. I think it's good. Now let me check the audio here. Let me check the audio here. Not this one, but this one. Oh, alright, it's good. Now let's check here. Let me check the audio. That's good. And now let's go back into the lessons. Now, as you know, we're doing the third stream of the day. This is about software engineering principles, which is like intermediate course. It's like intermediate basic because I need to review some of the concepts. So we're just doing it.
So far, you've been able to create a fully portable Python package, and you've even added functionality to your package by utilizing functions. We'll now look at how you can use classes to strengthen your package's functionality. Object-oriented programming, or OOP, is a great way to write modular code and reap the benefits of modularity, such as easily understood and extensible code. We'll cover some aspects of OOP, but if you want a deeper dive, I recommend the dedicated DataCamp courses. Let's jump into some code. In Python, OOP can be utilized by writing classes. Here we see a minimal class implementation. To start, we use the keyword class, followed by the name of our class. According to PEP 8, our class name should be written in camel case. That is, our name should start with a capital letter, and every word in the name should have a capital letter as well. Unlike function and package names, class names should never contain underscores. Next is some documentation that will appear when a user calls help on our class. We'll cover the details of this particular documentation formatting later in the course. Last, we see a function with a familiar name, init. Similarly to your package's init file, this will initialize everything when a user wants to leverage your class. You might have noticed we use a variable named self. We'll get back to this in a couple of slides. To make our class easily, you might have noticed we use a variable named self. We'll get back to this in a couple of slides. Named self. We'll get back to this in a couple of slides. Self. We'll get back to this in a couple of slides. To make our class easily accessible, we can add it to our init file just like we've done with functions before. We use relative import syntax to import myClass from the myclass.py file in the same directory. We can now import the package and access myClass easily. Now let's create what's known as an instance of myClass. To do this, we call myClass like a function and supply a string to the value parameter. Calling our class like this tells Python that we want to create an instance of our class by using the init method. Recall that myClass's init method set the contents of value to a variable we referenced as self.attribute. Users can access this attribute by referencing my_instance.attribute. Note, nowhere in this script do we see the self object that we used when defining our class. Let's look more in depth at the use of self in our class's init method. Self is, in essence, a way to refer to a class instance even though we don't know what the user is actually going to name their instance. When defining typical class instance methods, like init, self is the first argument. However, if you recall creating an instance of my class, when using init, the user doesn't need to pass a value to the self argument. This is done automatically behind the scenes. Once in the method body, we can use self to access or define attributes. The user can then access these attributes by using their class's name in place of self, like we did in our script. Technically, we can use a different word than self, but this is a very strong PEP 8 convention, and not abiding by it will make your code very hard to read by your collaborators. We've covered how to add a minimal class to our package and leverage its functionality by importing our package. Additionally, we touched on the role of the self convention in writing classes. Let's jump into some exercise to practice.
Okay, so writing a class for your package. We've covered how classes can be written in Python. In this exercise, you will be creating the beginnings of a document class. Alright, so we have the counter utils and we now need to create the document.py, which is here. No, document.py, okay, there. And in there we define this document class. And then here I'm able to create, so the same as in the modules. And then in here is this thing that you create. So here I'll copy this, then here it will be self. And here it will be self, I assume. I'm gonna run the code. No. So here's self and here's self. Okay, and in the second one, you have just completed the good. Okay, this is a really simple class. So okay, in the init of here, we want to import that. So what you need to do is from document import document, this one here, and then we run the, let's run this in. Submit the answer. This is good. So importing user login, so we need to import the text analyzer here, and here in the text analyzer we create a document which is going to be the text is the data come tweet, and we're gonna print my document that it was text, I think. Yeah, that's good. So in that case we need to do, this will be number 6 underscore word count, no, creating word object, and in this case I can just copy this here. So we do Python 6, and we need to go to software engineering principles, Python 6. Can you complete this file so I can run it? Okay, so far in data camp should be good. So now we're good with this. Okay, now leveraging classes.
In our last lesson, we created a document class that currently only serves as a container for our text. Let's look at our current definition of document and talk about how we can improve its functionality. Right now, the class is just a container for the user-provided text. This doesn't add much value for our user. In order for our document class to be more useful, we can add more attributes and methods besides init. For example, let's say that in our workflow, we always want to tokenize our document as a first step. Tokenization is a common step in text analysis. It is the process of breaking up a document into individual words, also known as tokens. As we've learned, init is what's called when a user wants to create an instance of document. This would be a convenient location to put a tokenization step. Placing the tokenization process inside of init will ensure our document is tokenized as soon as it is created, and this will save your users the trouble of thinking about this step. Our new init method might look something like this. You can see that we added a line that calls self._tokenize and dumps the output into an attribute named tokens. So where does _tokenize come from, and why does it have an underscore in front of it? Let's first answer the question of where the method came from. Since this course isn't focused on teaching text analytics, we aren't going to cover the tokenization function implementation. We'll simply import a function to do it for us. In a way, this demonstrates the beauty of modularity and Python's community. Oftentimes, there are functions already written by someone in the community, and all you need to do is find out where they are and import them for your own use cases. Moving on to the definition of _tokenize. We only pass one parameter to the function, the prescribed self convention that will represent an instance of the document object. Since the tokenize function is already written, all that's left to do is call it on the text attribute, and voila! The tokenization process will now be completed automatically as soon as a user creates a document instance. So why did we use a leading underscore when naming _tokenize? The reason we added the tokenization process to the init method is that we wanted tokenization to happen immediately without the user having to think about it. Because of this, the user doesn't need to call _tokenize themselves. In other words, this method doesn't need to be public to the user. According to PEP 8, non-public methods should be named with a single leading underscore. This signifies to the user that the method is intended for internal use only. Users can still use non-public methods in their own workflow, but they must do so at their own risk since the developer did not intend for them to do so. The risks of using a non-public method in your own workflow include little or no documentation, and the function's input or output might change without warning when the developer updates their package. You've now seen how we can add more functionality to our document class. In the upcoming exercises, you'll add additional methods to streamline our text analytics workflow. You'll even write your first non-public method.
All right. So let's create now the 7. It's going to be non-public method. So here we do self work counts. There will be. So here you call the tokenize. So here count words. Len, and this will be self tokens. Right in here, I'm gonna do the document in the from the init. I'm gonna do this, and then oh. No, because this is private. So this is underscore. Here is underscore. So it should be like this. So this will return me a tuple. So here I can do the. Can you complete this file now? Because we already have some tokenizer in some of the other files, I just wanted to pull it to maybe we are gonna. I remember it was doing something like tokenize, and we were using some of the models to tokenize the word and split it into tokens that can be consumed by ChatGPT. So in this document, we need to put the text, and here we should pass the data count tweets. Then print the first 5 tokens. So it will be data count.doc, and here I will get the tokens. And then here I will do the data counter, because here's the word counts. Yes, please do. So here will be or counts because this is an instance of counter. So here I'm making a basic regex. And here in the utils I'm creating a basic tokenizer, which is like not a good tokenizer, it's just a sample one. But anyway, this will run. Here I have the documents tokenizer. Here I have the counter for the counter model. So yeah, I think in the number 7 or 8. And this is called using class functionality. So in this case we're gonna again call the document, but in this case we're gonna pass the tweets, we're gonna print the first 5 tokens, and then we're gonna print the most common. Like this is a tuple, so this is the number 8. Nice. Documents not defined. It's because the same as here. What do you mean text analyze? It is because here we need to import it like this. And then it would work. Data count tweets. And like that. Here are the first 5 tokens. Here's the count in general. Nice. Class and dry principle. Let's see.
Great work on the exercises. Your package now has a handy document class that can be used to analyze any generic text. What if we wanted to specialize this functionality to focus on the social media data we've been analyzing? To do this, let's make a social media class that performs the same functions as the document class, but can additionally analyze social media specific things like hashtags. However, when making this social media class, we want to preserve the document class as is to be used for more general analysis. So how can we do this? A first guess might be to copy-paste the contents of the document class. This violates what is known as the dry principle in software engineering. The dry principle is a great rule that, if followed, can help you write modular, readable code. Dry stands for don't repeat yourself. There are many ways to follow this rule, such as writing reusable functions.
Why to create a new name? I don't agree with this, but okay.
Classes, and packages. The benefits of staying dry are not only saving time by reusing code, but also if you copy-paste code and later find a bug, you have to remember everywhere you've pasted the buggy code and fix each instance individually. If you stay dry, you only need to fix the bug once. In the case of extending the document class to be a social media class, we can stay dry by using the object-oriented programming concept of inheritance. With inheritance, we start with a parent class and we pass on its functionality to a child class. The child class inherits all the methods and attributes of its parent, and we're able to add additional functionality without affecting the parent class. So how do we leverage inheritance in Python? To start, let's see how the child's social media class fits into the package structure. It will live as a single file named after the social media class at the same level as the rest of the package's code. Now let's see how to actually write a child class that uses inheritance. You'll be writing the code for the social media class, so we'll stick to a generic example. First, we import the parent class for use in defining our child class. To let Python know we're using inheritance, we pass the parent class as an argument in our class statement. Last, we call our parent class's init method. Remember, init builds an instance of a class, and it also accepts self as its first argument.
Okay, so I define the class.
With this call, we're building an instance of parent class and storing it right back into self. This means that self now has all the methods and attributes that an instance of parent class would. We can now use self as normal to build an additional functionality unique to child class. Here, we just add an attribute. With our definitions, we now create an instance of our new child class as we've seen before, and then access attributes from both the parent and the child. Using inheritance like this can lead to short, easy-to-read definitions of children classes that are jam-packed with functionality of their parents. We just covered the important concepts of dry and class inheritance. You'll now use both of these concepts by building a custom social media class that extends the document class you've already written. Good luck!
Noise. So here is probably a new file, and this is gonna be called social media. That is gonna inherit the document and the social media that and the document init. So it's gonna create a social media is gonna inherit all of the properties of document. It's gonna instantiate with all of the properties that you instantiate when you create a social media. So when you init this, and whatever the text it is, you initiate the document with this. Okay, so for that we need to do social media. Then in here we do this. Then from here we do from document imports document, and we do this here. That's pretty much it. So adding functionality to a hashtag to child class. Okay, so this is gonna have, this social media is gonna have all of the functions of the methods of the document plus the methods that we assign here. So basically now we're adding the count hashtags. So only filter attributes, so only words starting with hashtag remain. So maybe I'll do here help. So help on function filter workers in the model main. So I send here the words count on the first char. So I should send here self that word counts, and then after that I should send the first char, which is going to be the hashtags. And then in here I'm going to do this. Then we submit, the answer should be good. So we do the same with the count mentions. And then in here we should do self.count mentions. In here we do this, we do this. We also need to init with the document. looks good. So now the social media inherited the all of the properties of the document, plus it has extended many more methods using your child class. So here we should import the text analyzer. Okay, so now we're gonna do 9 using extended class. So from here we do this text analyzer. So now here we do social media, and it's gonna, the social media is gonna create a document with the token, the words, the words, word counts, and it is also gonna create the hashtag counts and mention counts just right away. So basically, okay, I'm gonna make this private and auto executed when created. So basically when I do this and then this is tweets, and then here is gonna, from the social media, it's gonna filter this. So it's gonna still return me the counters, but in this case it's gonna be called DC tweets. So it's gonna be mention counts, and from the plot the most used hashtags. So from the counter here, I should do the plot counter, and then in DC tweets, I'm going to plot the mention counts. From text analyzer in Pro social media. Yeah, and it plotted that. And from here, we're gonna do the same here. We're gonna go to the 9. We're going to print this here. And we're gonna do Python 9. And I just realized that in this social media, we didn't do the filter word count. So we're gonna now please complete this file. I think it is missing the and it's because here in this utils, no, in this init, we need to also import the social media. And then we're going to the next multi-level inheritance. Oh, we're going fancier. Let me drink some water. This should be from social media. Yeah. Oh, so it was here. I know it wasn't. Okay, so it's gonna. Let's proceed. It found the bugs faster than I did. So yeah, it's gonna. Here didn't make a change. Here it defined a new filter word count. Here in the social media. Oh wait. Here, for example, it did something wrong. Override documents tokenized or the symbols are kept. So here's this is gonna stream by word because it only wants to keep this. Okay, maybe this is an overriding, which is completely fair because here it was just overriding by. Here the tokenize was imported from here, and here it was making this split. But in our case, we want to keep the. We want to keep this the words together with these symbols. So then we need to do this kind of regis that is gonna cut the strings. Okay, so now it should work. Data comes it's not defined. And let's do this at Luis, okay? Because okay, here's one count of because here is doing the plot of the mentioned counts, right? Okay, let's do the plot of the other one, which is the hashtag counts. Here we're gonna have richer info. Probably just gonna be one wire because there is only one of each one of them. Anyway, we understood. It's okay. Let's go here.
Great job on creating the social media class for your package. Thanks to the document class and inheritance, you were able to quickly build up the class for a more specific task. But what if we wanted to go even more specific? The social media class has some general functionality dealing with hashtags and mentions that works across multiple social media platforms. If we wanted to include functionality about retweets, it wouldn't be appropriate to include in the general class. Instead, we can create a tweet class. So how can we do this without losing the benefits of both the document and social media classes? With inheritance again, of course. We've seen before that a child class can inherit from a parent class. We can continue the family tree again with inheritance. With multi-level inheritance, our child class is all grown up and can pass its functionality on to its children. Thanks to inheritance, we pass along the traits of all prior classes in the family tree. Note that in the graphic, we only have one inheriting class at each level, but we are by no means limited to this. Multiple classes can inherit from the same parent. In fact, one child class can inherit from multiple parents. This more advanced OOP concept is known as multiple inheritance. We won't be covering it in this course, but it's good to familiarize yourself with the definition in case you hear of it out in the wild. Let's code up an example of multi-level inheritance. We'll start with the inheritance pattern we've seen before. Here, we define a parent and child class that inherits from parent. We could do this differently by using the super function. Instead of directly calling the init method of parent, we use the super function. This makes no functional difference in our code here, but it has some advantages in maintainability and when implementing multiple inheritance. However, there are some gotchas that can arise with super and multiple inheritance. You can check out this companion data camp tutorial to learn more about it. Let's continue the family tree. To create a grandchild class that inherits from superchild, we use the same super syntax in its init method, and voila! If we create an instance of
Okay, but just in case, here when we're doing this document init, so we're just passing basically the same. So I guess in the super, what I'm doing is just
child, we can see from the output
we're not passing any properties here,
that
so
each init method in the family tree was called. If you're using inheritance, it's sometimes hard to remember what attributes and methods your class has at the end of it all. If you're using an IDE, then generally you can use tab complete to get a list of suggestions. However, if you want to get the info from the console, you can use either help or the dir function. Help is a good option in most cases, but it will only include public methods in its output. Using dir will print a fairly exhaustive list of what your class has under the covers. The list includes methods that come with our class object by default. Near the end of the list, you see all the methods and attributes that you personally programmed into the social media class. dir can definitely come in handy, but a warning from the documentation. dir is supplied primarily as a convenience for use at an interactive prompt, so it's not advised to use it in your scripts. We just covered more about how powerful inheritance can be. In the exercises, you'll use multi-level inheritance to create a tweet class.
Got it. So from text analyzer, we need to import text analyzer. So from text analyzer, we create the document. Yeah, and then from here, use dir to show my. So here in the first one, I have my doc. It's gonna return me a document of like the object, and then here I do the dir in my doc, and I'm gonna see all of the attributes it has. It's class dog. Plot counts is here. Okay, import text analyzer. The plot method. So I need to help my dog that, and here it is, plot counts. And here run help on the plot method you discovered. So here, so basically I can do the plot counts to do the help, so I can see this, and then my dog plot counts, plot the word counts of my dog, and then I run this, and then I plot it. Okay, creating a grand okay, these tweets. So here we have, and here we have text. So social media, and so here we should do self that. How was that? So here we should put social media, and here we should do social media init self retweet, self process retweets, process retweet. So in this, I should pass the text. Define retweet text use help to complete the call filter lines. So so in here, param text, first charge. So I should just do this. I don't need to do. Oh, or I can define it, right? Like first chart, and here text. So it wants me to do super init. Okay. So I should create another, like the social media here, but with the, we should insert it in here. Okay. Okay, so in this case, we need to not do this, but you should create another one called tweets.py. In here we define this. In here we should do tweets. Please complete this file. I think it's here. It's missing to define these filter lines. The social media, we should return social media object. We don't need this, we don't need this, we save, and then we autocomplete. So basically it's instantiated its parent, and the parent of his parent is creating the retweets. And in here I'm extracting it's creating a social media object and putting it into retweets. I just need this new function here, filter lines. Okay, so from here I'm gonna import the text analyzer, and in here I'm gonna create text analyzer and call the object tweets, the method, the class tweets, using the data camp tweets, and it should be good. Then in my tweets I should use the plot counts, which is the social media. There is a method called plot counts. No, maybe the document there is a plot counts. No, so then I'm gonna do help my tweet plot counts, and let's see. So maybe I should So maybe I should do here help. Like this. Text analysis is also not defined. So maybe I should do deer to check how is this defined. If you have now defined tweets class inherited from the account social media. Okay, so then I don't know. This is the correct way to specify how the plot. So it says my tweet is not defined. Okay, maybe I'll reload the page, because sometimes it happens that I need to reload the page to finish this. Give me 1 second. So I need to do help. My tweets plot count here. Okay, maybe I should run the code first then. Okay, now first I need to run it then. Okay, plot counts, attribute. Counters address of the most common. So I should use this for the hashtag counts. Okay, and then use the plot counts of the retweets to plot the most used hashtag counts. So I should do like this. Aha, because it already instantiated another method here called retweets, and inside of it is plot counts. Okay. So I should do the plot counts, but with this. Okay. So here I'm gonna do 10 multiple inheritance. And here, of course, I have to make sure that I import the text analyzer, that the text analyzer imports also the tweets. So in the tweets is define a process retweets. It's gonna create a social media, and here's the retweets. So the retweets are here. And then in the retweets, we have the plot counts, which is in the social media. And the plot counts are not here, but they are in here probably. No, actually none of them. It is. But the retweets account object. So the retweets is so we're in 10 here. This is a social media object. It's a social media object, and the social media object should have like the K, but it doesn't have it here. And let's check if it has here. Correct. Can you check this file and complete the missing parts? Because I think that if that's the case, we need to, in the document, which is here, we already have this, but now here we need to define a new method here that is called plot counts, which is something that we didn't define in none of them, but now we need to define it. Let's just like allow the so yeah, let's see, that data come is tweets is undefined sample. Okay, now doesn't exist in any class. Yeah, screen to run. Yep, yes please. So yeah, because it was missing the example, also the parent should have the words counts, which wasn't done there. Text. Now we need to pour the tweet from, yeah. Now create the sample. And now it has the text analyzer, the plot counter. And this plot counter it's coming from the utils, counter utils, which is from here. That is gonna receive a counter and the most common. So in this case, when I do this, I pass the hashtag counts, and it's gonna plot the 5 most common. So if I execute the 10, uno, then I will execute the 5 most common. But in this case, I only have like the text is too short, so that's why I was doing that. Okay, now documentation. This is the last part, and first we need to walk the dog, eat, run, make some video, and then we're gonna come back later with the last topic. And this is the last topic, of course. And then we'll have only one left course, and we will have finished the career of AI engineer associate for developers. And then we will need to make 3 projects, 3 applications in Plato's, and 3 contributions to open source projects. So in basically we'll have like 9 different things to do. We think probably 1 week. So let's take a break.